Hello students, welcome you to this session. So we are studying set language, one of the very simple topic. So we studied some results and based on that we did some few questions in the last class. So today we are going to continue. So mainly what is finite set? So you can count the number of terms, right? That is finite set, then infinite set, set of natural number is going on, right? So that is infinite set. Then disjoint, you take the intersection, common elements. If nothing is common, then we say disjoint sets. If there are some common elements, we call it as overlapping sets, right? Then you studied singleton set. If there is only one element, we call it a singleton set. Empty set, if there is no element, we call it as what? Empty set, right? So overlapping, all these things we studied, right? Then today we continue a few more sums. Also you studied equal sets, equivalent sets. You are remembering? What are equal sets? Exactly the same element, then equal set. Equivalent set means cardinal number. You count the number of elements. If the number of elements are same, n of A equal to n of B, then you can say they are equivalent sets. Okay, now let us go for the second sum. Identify the following sets as finite or infinite. Finite or infinite. See the first question. It is given in which form? The set of all districts in Tamil Nadu. Which form? Three forms are there, right? To represent a set, you can use three forms. One is descriptive form, then set builder form or rule form. Another one is roster form. This is which form? Descriptive form, yes. The set of all districts in Tamil Nadu. How many districts are there? Is finite or infinite? As on today, there are 38 districts in Tamil Nadu, right? So, number of elements, it is finite only 38, right? So it is a finite set. The question is, identify the following sets as finite or infinite. So it is finite. See the second subdivision, the set of all straight lines passing through a point. Suppose P is a point. Through P, how many lines you can draw? Suppose if I give 2 points, suppose A is one point, B is another point. Through these 2 points, how many lines you can draw? Through both A and B, you can draw only one line, right? But here P is a point. Through that point, how many lines you can draw? You can draw one line like this, you can draw a line like this, you can draw a line like this. So how many lines you can draw? You can draw infinite number of lines, right? So this set is finite or infinite? It is an infinite set. See the next one, third one. A equal to set of all x such that x belongs to Z and x less than 5. Which form is this? This is set builder form, right? Or rule form. Some rules are given, right? Z means what? Set of integers. What are integers? 0, 1, 2, 3, 4, minus 1, minus 2. That is set of integers. 1, 2, 3 onwards, that is natural number. With natural number, if you add 0 also, whole number, right? If you take negative integers also, that is called what? Integer. Okay, Z. X is a integer and x is less than 5. Less than 5. So what can you say? What is Z? Less than 5. Below 5. What numbers are there below 5? Below 5. Don't take 5. 4, 3, 2, 1, 0, minus 1, minus 2, etc. How many? We don't know. It goes on, right? So it has how many elements? Infinite elements. So it is a infinite set. The question is, identify the following sets as finite or infinite. So it is infinite. So number of elements is infinity. See the next one. B equal to set of all x such that, again set builder form, x square minus 5x plus 6 equal to 0. Okay, a quadratic equation is given. If they give a linear equation, it has one solution. Quadratic equation, there are two solutions. The quadratic equation has two solutions. If a cubic equation, x cube is there, then 3 solutions. If the power is n solutions will be there. Here the power is what? 2, x square, right? Highest power is 2. So if you solve it, you can find there are 2 solutions. How to solve? We'll study later in algebra. But anyhow, I'll tell you, you know how to do this. Factorization you studied in 9th standard, right? Sorry, in the lower class already you know factorization. So here Okay, look at this question. So B equal to set of all x such that x square minus 5x plus 6 equal to 0. So set of all x satisfying this condition. So it is called a trinomial. There are three terms, right? But see, the highest power x square is there, right? So we call it as a quadratic equation. You will study in detail. This year algebra will study that in detail, how to factorize a trinomial and how to solve it. And when you go for higher classes, this is one of the very important things. I'm not going to teach now how to solve it. I'll tell you how many solutions will be there. You see the highest power, x square, right? X square is there. So this equation has two solutions. If x cube is there, that we call it as cubic equation. Then it will have three solutions. Suppose x raised to 4. If x raised to 4 is there, then that equation has four solutions. Okay, here quadratic, so there are two solutions. But our question is, no need to solve and all, whether the answer is finite or not. Only two solutions, so it is what? Finite. So it is finite. Okay, now let us go for the next question. See the third one. Which of the following sets are equivalent or unequal or equal? So you must know the theory part, all the definitions and everything. You must know clearly the difference between equal set, equivalent set, then unequal. So equivalent set means number of elements must be same, right? So cardinal number, you count how many elements are there in each set. If the number of need not be the same element. Here 3 elements, the other set also 3 elements. You say they are equivalent. Number of elements are same, also exactly the same element. Order may be changed. Then we say they are equal. Then if it not comes in any of these two categories, we say they are unequal. They are unequal. So we can classify into 3. So see here, the first one, A equal to, so it is given in descriptive form. So I'm going to write it in roster form, right? So A equal to the set of vowels in the English alphabet. Set of vowels in English alphabet. So you know what are the vowels in English alphabet? A, E, I, O, U. So N of A equal, how many elements are there? 5 elements, right? So N of A, 5. Now let us find B. B is the set of all letters in the word vowel. Set of all letters. So already last class we did a question, right? So you write all the letters one after the other, but don't repeat, right? If there is any repetition, you write it only one time. Here, what are the letters given here? V, O, W, E, L. No repetition at all. So N of B, count how many elements are there? 1, 2, 3, 4, 5 elements, right? Number of elements are same. Don't conclude it is equivalent. You see whether they are equal or not. See whether the elements are same, whether the elements are exactly the same. Here A is there, but there A is not there, right? So they are not equal, but number of elements are same. So you can say they are equivalent. Okay, so write the reason here. N of A equal to N of B. Here N of A equal to N of B. Therefore, they are equivalent. They are equivalent sets. A and B are equivalent sets. Now let us go for the next question. Second subdivision, C equal to 2, 3, 4, 5. It is given in roster form, so straight away you can say N of C. N of C is equal to 4 elements, so you take what? 4. N of C equal to 4. D, it is given in set builder form, so change it into roster form. See, X belongs to W. W means what? Whole number starting from 0. But there is a condition. X lies between 1 and 5. X lies between 1 and 5. Only less than sign is there. Less than or equal to not there. So you cannot take the endpoints, right? You can't take 1 and 5 in between. Which numbers? 2, 3, 4. So 2, 3, 4. So N of D. Number of elements of D is only 3. N of C 4, N of D 3. They are not equal. So you can say here N of C not equal to N of D. So they are not equal. They are not equivalent. So your conclusion, they are unequal. Therefore, C and D, capital letters you use for set, right? C and D are unequal. Okay, now let us go for the next question. See this question, third subdivision. X equal to X is a set of all X. Inside that X is an element, so write small letter. Outside, name of the set, so use capital letter, okay. X equal to set of all X such that X is a letter in the word live. So X equal to, what are the letters you have? L, I, F, E. So how many elements are there? N of X equal to 4. There are 4 elements. And Y they have given here. What is Y? F, I, L, E. How many elements are there in Y? There are also 4. N of A equal to N of B, N of X equal to N of A. They are equivalent. Don't stop. When the number of elements are same, you check whether exactly the same elements. Listen. So here you have L. Yes, here also we have L. Second letter is I. Here also you have I. F. Yes, F is there. E. E is there. Order only change. In a set, order can be changed. So they are number of elements same. Also exactly the same elements. So you can say that 2 sets are equal. So here X equal to Y is okay. So X and Y are equal because they have exactly the same elements. Look at the fourth one. G equal to, it is given in set builder form, we write in roster form. Set of all X such that X is a prime number and that X must lie between 3 and 23. You can't take 3, you can't take 23, in between. So you very carefully read the question. Sometimes in some place they put less than or equal to, then that also should be included, okay. Sometimes first they put only less, the second one they put less than or equal to. So okay, see the question very carefully. Here in both the places you have only less than. So you should not take that 3 and 23. So other prime numbers between 3 and what? 23. So what are the numbers? After 3, what's the next prime number? After 3, 5. From first up to 100, you must know what are the prime numbers. So otherwise in the exam hall, you sit and think one by one, you may make mistake, okay? So practice it. So if you take 1 to 50, you count how many numbers are there. You can see 15 prime numbers are there between 1 to 50. 1 to 100, you can see 25 prime numbers are there. Okay, so you can write and practice what are the numbers. Okay, so here after 3, the next prime number is what? 5, then 7, 11, 13, 17, 19, then 21. No, 21 is not prime. You can divide by 3 table, right? 3 sevens are 21, so you can't take that. 23 is a prime, but you cannot take here, right? How many elements? 6 elements are there, right? So n of G equal to 6. Okay, one part is over. Now H is set of all X such that X is a divisor of 18. So 18 is divisible by which numbers? The factors of 18 you have to find. 18 is divisible by 1. 18 is divisible by 2, right? If you divide, remainder must be 0. 18 you can divide by 2 table. 18 you can divide in 3, right? 3 table 18 is there. 4, no. 4 4s are 16, then 20 only. 4 you cannot divide. 5, no. 6 you can divide. 6 3s are 18, right? 6 3s are 18. Then 9 2s are 18. Then 1 into 18 is 18. These are some easy methods. Okay, no need to check. Otherwise what happens, after 6, then 2 9s, right? 2 9s are 18. So that means you don't need to check anything in between. Otherwise, if you do everything, it will take a lot of time. Okay, so n of H. So how many elements are there? Here also you have 6 elements. N of G equal to n of H. Now we check whether the elements are same. There are 5 here, 5 is not there. Even 1 is not there, okay. So they are not equal, but number of elements are same. So you can say they are what? Equivalent, right? So here n of G equal to n of H. Therefore, G and H are equivalent. Equivalent sets. So hope you understood how to identify. Now let us go for the fourth sum. See what they asked here. Identify the following sets as null set or singleton set. So some sets given. Earlier we checked whether they are equal or equivalent, they are finite or infinite. Now we have to check the set is null set or singleton set. Null set or empty set or void set. Number of elements. No elements there, right? Number of elements 0. Cardinal number is 0. Singleton set, the cardinal number is 1, right? Number of elements is 1. Look here. A equal to, so it is given in set builder form, right? Set of all x such that x belongs to n. X is a natural number and that x lies between 1 and 2. Can you find a number between 1 and 2? There are numbers between 1 and 2, 1.5 and all there, but we want natural number. Natural number means after 1 it is 2 only. But here only less than sign is there, so you can't take 1, you can't take 2. Between 1 and 2, you cannot find any natural number, so your answer is what? Null set. Okay, so they asked to check whether it's a null set or singleton set, so you say A is a null set. Next one, B. The set of all even natural numbers which are not divisible by 2. Even natural number. Natural number means 1, 2, 3, 4, 5, etc. Odd numbers and even numbers. 1, 3, 5 are odd numbers. Even numbers are 2, 4, 6. So here you have to find set of even natural number. What are the even natural number? 2, 4, 6 and all. And one more condition, which are not divisible by 2. Can you say an even number? Can you say an even number which is not divisible by 2? Not possible, right? Even number means it must be divisible by 2. So you can't find an even number which is not divisible by 2. So there is no such number. It is an impossible thing. So here B is also what? Null set only. Okay, so B is null set. Okay, now see the third one. C equal to a set 0 is there, right? Which element is there? 0 is there. How many elements are there? How many? I'm asking how many. Number of elements you should say. Don't say 0. 0 is one element, right? So one element is there. In the set, C is a set in which if nothing is there, okay, there is no element 0, you can say null set. But there is an element. 0 is an element, right? So there is one element, right? So n of C equal to 1. So it is not a null set, it is a singleton set, okay? So now let us go for the fourth sum. D equal to set of all triangles having 4 sides. Superb, right? Set of all triangle having 4 sides. For a triangle, how many sides will be there? 3 sides, right? 4 sides means what's the name? Quadrilateral. If there are 4 sides, that is called what? Quadrilateral. So 3 sides, so 4 sides triangle, it is not possible. So your answer is what? Null set. So hope you understood how to identify null set and singleton set. Now let us go for the next question. State which pair of sets are disjoint and overlapping. So all the theory we studied. So now we are checking how much you study, how much you understood, right? So now one by one we are checking, right? Now which pair of sets are disjoint or overlapping? So here what you do, you find the intersection. That is common element you should see. Both the sets you take, we are not bothered about how many elements, there's no problem. We check whether there is any common element. Even one element is common, overlapping sets. If nothing is common, you say they are disjoint sets, okay? So here it is given in roster form. So just you can see, go through, you can find out F is, yes, F is there in both the places. That itself enough. So F is the element F. You can say F belongs to A and F belongs to B. F belongs to A and that F belongs to what? B. F is common in both. Sometimes some more elements may be there. So even one element if you show, that's enough, okay? So they are not disjoint. So A and B are overlapping. are overlapping sets. See the next one. Second subdivision, C equal to set of all x. X is a prime number greater than 2. Set of all x such that x is a prime number x greater than 2. So you cannot take 2. You take prime number greater than 2. So you can start from 3. 3, 5, 7, 11, 13, 17, 19, right? 23. It goes on. And D is set of all x such that x is an even prime number. Even prime number means only one prime number. So C is one set. It contains infinite number of elements. D is a singleton set. Now we want to check whether they are disjoint or overlapping. See, anything common? Here 2 is there, but in the other set 2 is not there. So nothing is common. So that is C intersection D equal to empty set. So this is a symbol we will study in detail in the next class. So nothing is common. That only we show like this, okay? So therefore C and D are disjoint. Are disjoint sets. Okay, nothing is common, that's all. See the third question. E equal to set of all x such that x is a factor of 24. Factor of 24. 24 by which numbers and all you can divide? 1, 2, 3 table 24. Yes, 3. 8 3s are 24, right? 3, 4 table. Yes, 6 4s. Then it won't go for 5. 6. 6 4s are 24. Then 3 into 8. Then 2 into which number is 24? 2 into 12 is 24. Then 1 into 24. So this is some easy method. Once you did halfway, then the remaining you can find like this. So no need to check one by one. Okay. So when you practice some questions, you'll find it very easy. So this is E. Okay. Then F you find out. F is set of all x such that x is a multiple of 3 and less than 30. Multiple of 3. 3 table you write, that's all. 3 table. 3. Now itself you can see, right? 3 is in both the sets, no? So it is not disjoint, overlapping. Anyhow, we write fully. Okay, 3 table. 3, 6, 9. You say, what are the numbers? You know 3 table, right? 12, then 15. After that, yes, 18, 21, 24, 27, 30. No, you cannot write 30. Why? Less than 30. So you write only up to 27. There are some common elements, right? So 3 is common, then 12 is common, 24 is common. There are some common elements, okay? So just to show one element, that's enough. Here 3 belongs to E and 3 belongs to what? F. So there are some common elements. So E and F are overlapping sets. If nothing is common, we say disjoint. Here they are overlapping sets. Okay. Now let us go for the next question. Question number 6. See what is given here. If S equal to square, rectangle, circle, rhombus, triangle. So immediately every diagram should come in your mind. First one is what? Square. You know what is square? Yes. So just imagine square. All the 4 sides are equal, right? How many sides are there? 4 sides. Rectangle. Yes, like your TV, right? 4 sides, only the opposite sides are what? Equal, parallel. Circle, you know your familiar number, right? Circle, okay. Then rhombus, what is rhombus? 4 sides, but all the 4 sides are equal. It won't like square, slightly slanting, right? Square also 4 sides equal, but straight, right? It will come straight. Rhombus, all the 4 sides are equal, like parallelogram, slanting. Then triangle, you know, 3 sides are there, okay? So just keep in your mind. Now we see what they ask, list the elements of the following subsets of S. So from here you are going to frame some sets under the condition. They are going to give some condition. Now from this, which one satisfy that condition we are going to write, okay? The set of shapes which have 4 equal sides. Condition is 4 equal sides. Only from the given list you have to take. 4 sides are equal. Can you tell me? Square you can take because 4 sides are equal. Anything else? Rectangle you cannot take, only the opposite sides are equal, not all the four. Rhombus, yes. In rhombus also all the four sides are equal. So your answer is, you write it as a set. What are the elements you write? Square and rhombus. Then the next one, what's the next question? Set of shapes which have radius. Set of shapes which have radius. For square there is no radius. Only for which one you have radius? Circle, right? Only for circle we have radius. So it is circle. Okay, now let us go for the next question. Third one, what's the question? The set of shapes in which sum of all the interior angles is 180 degrees. Sum of the angles in a triangle is 180 degree. In triangle there are three angles, right? If you add all the three, your answer is what? 180. So here your answer is what? Triangle. Only in triangle. So what's the next question? Set of shapes which have 5 sides. 5 side means it is pentagon, right? So here pentagon is not given. Square 4 sides, rectangle 4 sides, circle no sides, right? So rhombus 4 side, triangle 3 side, 5 sides nothing. So what is your answer? It is what? Null set, right? Set of shapes which have 5 sides, null set. Okay, it is a null set. Okay, so hope you understood that. Now let us go for the next question. Question number 7. Very important question, so listen very carefully. Normally people make mistake in this sum, so listen carefully. So like these things you mark it. Last class I taught one sum, you're remembering the cardinal number, the leap year. Okay, so commonly the students make mistake. So you help your friends also. Okay, so what is leap year? Why the century year we are checking whether divisible by 400 or not. Okay, so you must try to understand all these things. Okay, now listen here, sum number 7. If A equal to different type of set, right? First time you are seeing this. So A equal to, the first element is A, second element is, this is the second element, okay? So this is one element, this is another element. Some set bracket AB. Okay, that is second element. So only how many elements are there? 2 elements. Write all the subsets. Number of subsets, there's a formula 2 raised to n. Here 2 raised to, how many elements are there? Only 2 elements are there. So 2 square, 2 into 2, 4. So you are going to get 4 subsets. So listen how to write it. First you write set itself, right? Set itself means A, AB. Okay, this is one subset. Set itself. What they given, write as it is. Second one, empty set. Now singleton set. First element alone. Write it as a set. Simply don't write A. It is meaningless. Write it as a set. Now second element, write it as a set. Here only students make mistake. Second element. What is the second element? This is the second element. This is the second element. Write it as a set. Very important. 2 brackets will come. Because the set AB is one element, write it as a set. Okay. And for the same question, if they ask power set, what you do? What is power set? Set of all subset. Outside totally you put one more set bracket, right? For everything together. Okay, fine. Hope you understood. So all these things you watch this video again so you can understand better. Shall we go for the next sum? Write down the power set of the following sets. Okay, it's very simple thing. Last class, those who attended, those who practice, it's nothing. You write all the subsets, write them within a set. Set of subsets. Write all the subsets, write it as a set, that's all. So power set of A, P of A. Write down the subsets first. One is set itself, AB, empty set. Singleton set, A, B. So these are the subsets. Set of subsets, write everything as a set, that's all. So set of all subsets. So this is power set. Now see another one given, B. 3 elements. Can you tell me how many subsets will be there? 2 raised to n, 2 raised to 3. 2 raised to 3 means 2 into 2 into 2. 2 to 4, 4 to 8. So 8 subsets will be there, okay? So they asked to find the power set, right? So P of B you have to find. First you write all the 8 subsets, then for everything together you write a set bracket, okay? So first one set itself, second empty set, 2 you got it. Take one at a time. 1, 2, 3. Now 2 at a time. 1, 2, 1, 3. Then starting from 2, 2, 3, that's all. So what are the things you write? 1, 2, 1, 3, 2, 3. Check whether you're getting 8, 1, 2, 3, 4, 5, 6, 7, 8, right? So don't leave it. These are subsets. So set of subsets. So write the whole, everything you write inside a set. Now let us go for the next question. 4 elements given. So listen, PQRS, power set of D. 4 means it is 2 raised to 4, right? 2 into 2 into 2 into 2. So 16 you are supposed to get. 16 elements. One is set itself. PQRS, empty set. Singleton set, taking one at a time. So P, Q, R, S. So now we got totally 6 you got it. Now 10 more. For that taking 2 at a time. Last class I explained 2 at a time. Starting with P, what you can write, tell me? PQ, PR, PS. So we write that first. PQ, PR, PS. Then starting with Q, QR, QS. Don't come back. QR, QS. QR, QS. Then from R, it is RS, right? So these are the subsets. Write them as a set. So outside you put a set bracket. Okay, you try to write in 2 lines. Okay. So that is important. Look, another one. E equal to empty set. E equal to empty set. Empty set means no element there, right? What is the cardinal number? 0. So 2 raised to 0. What is 2 raised to 0? 1. So the set itself, that is empty set. Okay, empty set, that is the only subset. This is the only subset. Write it as a set. So this is power set of E. Or you can write like this. Empty set is a subset. Write it as a set. Okay, so you can write it in any one of this way. So hope you understood. So only thing you remember, power set. Power set means set of subsets. Okay, now we go for the next one. Find the number of subsets and the number of proper subsets of the following sets. So you know, number of subsets, the formula 2 raised to n. Improper subset, only 1. What is that improper subset? The set itself is called what? Improper subset. All other subsets are proper subsets. Suppose there are 8 subsets. 1 is improper, remaining 8 minus 1. So you reduce 1. You will get number of proper subsets. So if you know total number of subsets, just you reduce 1 to get the number of proper subsets. Improper subset always 1 only. Okay. So look here. Here n equal to n of w equal to 3 because red, blue, yellow, there are 3 elements. So number of subsets you write first. Number of subsets. The formula 2 raised to n, here it is 2 raised to 3. 2 raised to 3, don't, some of you think it is 6, right? So don't make mistake. 2 raised to 3 means 2 into 2 into 2, right? 2 into 2 into 2. 2 2s are 4, 4 2s are 8. Sometimes even in higher classes students make mistake. Okay, so to be very careful in this. Okay, this is number of subsets. Don't stop here. Number of subsets and number of proper subset also they asked. So number of proper subsets. What do you do? Total number of subsets 8. You subtract 1. Why that 1? 1 is improper. Remove that. The remaining are proper subsets. So 8 minus 1, the answer is what? 7. Look at the next one. See, it is given in, we don't know how many elements, right? So x equal to, again set builder form, write in roster form. X equal to set of all x square. So x square is your answer. X is a natural number. So x value 1, 2, 3, etc. and x square, when you square, it is less than or equal to 100, less than or equal to 100. So, first you take natural number, you start with 1. If I put 1, what is x square? I'm giving x equal to 1. X is a natural number. X is a natural number. Natural number means 1, 2, 3, 4, etc. You keep on give like this and you square it. When you square, you will get some answer. If I take 5, 5 square, what you are getting? 25. And that answer must be less than or equal to 100. If I take 15, 15 into 15, 225. It is more than 100. You cannot take that. Okay. So from 1 onwards, you start. If you take 1, 1 square, 1 into 1, 1. So you can take it. X square is your answer. Okay. If for x, if I put 2, 2 square is 4, less than 100. So you can take 4. If I substitute 3, x square, 3 square, 9 you can take. These are the square numbers. You take all the square numbers. 3 square is 9, 4 square is 16, 5 square 25. You can take 25 because 25 is less than 100, right? 6 square is 36, 7 square 49, 8 square 64, 9 square 81, 10 square 100. 100 is allowed because less than or equal to 100. Up to 100 you can take. 11 you don't take because 11 square is 121. It is more than 100, right? So don't take, you stop here. So n of x is equal to how many elements you count? 1 square, 2 square, up to 10 square. So it is 110 terms, okay? So n, number of elements is 10, but the question is number of subsets, right? So number of subsets equal to 2 raised to n. That is 2 raised to 10. You know what is 2 raised to 10? 2 into 2 into 2 into 10 times. After the class, you work it out, okay? 1024 you'll get. Don't use calculator. You keep on multiply and check it, okay? 1024 is a, try to remember this number, 2 raised to 10. It will come quite often. 2 raised to 10, 1024, okay? Remember that. Then number of proper subsets we need, right? Number of proper subsets. Sometimes when you go for the examination, they may ask number of improper. So read the question very carefully. Only the 2 letters change the answer, right? Improper. Improper means only 1. Here proper subsets. So total number of subsets 1024. You remove that improper. So your answer is 1023. Okay, so that's your answer. Now let us go for the last question. See, n of a equal to 4, n of p of a. Number of elements in power set. The formula 2 raised to n, right? So here n equal to n of a is n. n is 4. n is 4. The question is n of p of a. n of p of a. That is the formula. Number of elements in the power set 2 raised to n. Here it is 2 raised to 4. 2 raised to 4. 2 into 2 into 2 into 2. 4 times, right? So our answer is what? 16. Next you see n of a equal to 0. So n equal to 0. The question is n of p of a. The formula 2 raised to n. That is 2 raised to 0. What is the value of 2 raised to 0? 2 raised to 0. Any number raised to 0, the answer is 1. So 2 raised to 0 or 5 raised to 0 or 7 raised to 0, the answer is 1. Now look at the last question. n of p of a, they given us what? 256. n of p of a equal to 256. They asked n of a. In the previous questions and all, n value given, they asked to find n of p of a, right? n of a given. But now, n of p of a given, they are asking you to find this. You have to n value, that is only n of a. So what do you do now? n of p of a, the formula 2 raised to n. n of p of a is what? 2 raised to n equal to 256. So with this, you cannot find n value. So left side is 2 raised to n. So right side also you write 2 raised to something. 256. You divide by 2 table. Prime factorization you have to study in the lower class, right? 2 table, 1 time, 1 to 2. In 5, 2 times. 2 2s are 4, balance 1, 16. 8 2s are 16. Again 2 table. 6 2s are 12, right? 8 4 times, 64. Again 2 table. 32. Again 2 table. 16. Again 2 table. 8. Again 2 table. 4. Again 2 table. 2. How many count from here? 1, 2, 3, 4, 5, 6, 7, 8. So 256 is 2 raised to 8. Now you can see the bases are equal. Here 2, bases are equal. So you can say the powers are equal. So you can say n equal to 8. So what can you say? N equal to 8. N equal to 8. That n only n of a. Number of elements a equal to 8. Okay. So two types of questions they can ask. They give n of a and they can ask you n of p of a. Sometimes n of p of a they give. They'll ask you what? N of a. Both the types you studied thoroughly. So that's all this first topic. So next class I'm going to teach very interesting one, operations of set. Okay, we'll continue in the next class.